My research is in outer planet magnetospheres and auroras. Specifically, I'm involved in spacecraft orbiters in the outer mission, both NASA and ESA. The fascinating thing about plasmas is that they actually make up more than 99% of the visible universe. The sun essentially is composed entirely of plasma, and it has plasma particles propelling away from the sun called the solar wind, and that immerses all of the planets in our solar system. We are basically swimming in a soup of plasma. By sending spacecraft up there, we are making continuous measurements of plasma in its natural habitat. Now, in the planetary context, which is what I'm interested in, plasmas play a major role in various areas. So for one, the auroras, plasmas are essentially what create the aurora, because you have electrons that are precipitating or falling onto the polar atmospheres of these outer planets. So these planets, although they're very far away from the sun, they're still very hot. And that's due to their very powerful auroras, and that's largely driven by plasmas and plasma processes. Jupiter's magnetosphere is extremely enormous. On one end, it extends to about 100 times the size of Jupiter, but on the back end, the magnetosphere extends all the way out to the orbit of Saturn. Jupiter's moons, they're not inert bodies like our moons, they're actually conductive, and that's largely because some of them have an ocean beneath their crust, but also some of them have an atmosphere or an ionosphere that's sort of a charged envelope of tenuous plasma around their surface. Since the magnetosphere is so large, it envelops all of these moons and their orbits. They're conducting, and any conducting material in the presence of a magnetic field can generate electrical currents. And so there's always a continuous interaction, an electromagnetic interaction between Jupiter and its moons. Juno is an extraordinary mission. It's the second orbiter around Jupiter, the first being Galileo, but it is the first polar orbiter of Jupiter. So as Juno flies over Jupiter's aurora, it is sampling magnetic fields that are connected to the aurora below in the atmosphere. And these magnetic fields act like highways for these charged particles that eventually crash into the aurora before. And along with it as well, it carries a set of cameras, so it takes global images of the auroras as well. So what we do essentially is we piece together local measurements of the electromagnetic fields and remote measurements of the aurora and try to connect the beginning to the end and get a full understanding of the process. The mission is evolving into a sort of system-wide mission. Flybys of Jupiter's moons have become a possibility. 2021, Juno had one flyby of Ganymede, which is Jupiter's moon that has its own magnetic field. And then last year, it made a flyby past Europa, which will be the target of the Europa Clipper mission. And Europa is a very interesting target because it's believed to have an ocean beneath its surface and hopefully target the question of habitability in systems beyond our planet. The biggest lesson that I've learned, the whole point of research is to do something that someone's never done before. Running into a brick wall or a dead end, having to turn around, going back to the drawing board, doing things all over again, failing, often many times, is inevitable. And it took me a while to embrace that. But I think once I did, it's made me a much happier researcher.